In this video, we're going to take a look at designing a custom cam in Autodesk Fusion 360. And with this, we're going to utilize the motion graphs that we generated from activity 4.1.6, Design a Cam. This is the one provided in the curriculum. And here we can see that the top of the follower measured to the top of the box. Motion graph has been created. And then from the displacement, we've been able to plot new points which represent the radial dimension of the cam. Looking at these points, at 0 degrees, the minimum radial dimension of the cam is 1/2 inch, and each one of these increments represents 1/8 of an inch as we go and move forward. So here you'll see the next point would end up being 0.625, the next 0.75, and then the next 0.875 until we reach 1 inch in this particular case. So looking at each one of the triangular points, I'm going to look and see where the measurements are. I already have them written down, and what we're going to do is we're going to use those in Fusion to create our custom cam using a polar grid file. So I'm going to move into Fusion, and inside of here I'm going to go ahead and say show data panel, and I already have a polar grid set up in this particular file. So I'm going to go ahead and open this up. I've already previously uploaded this into my data panel, so I'm going to go ahead and close that down. And right now I'm going to go ahead, before I make any changes, I'm going to go to File, Save As, and instead of having it Polar Grid, because I don't want to overwrite this file, I'll call this Custom Cam number 1 and click Save. From here, in order to use the grid, I'm going to go down to the sketch that's in my model history tree, right click on it and choose Edit Sketch. From here, you'll see a lot of dimensions already set up, but mainly we're going to utilize points and some measurements to help us out. So the radial dimensions that we have going on here may go through and give us an idea of the sizing we have for the cam. Clicking on Create, I'm going to choose Point. And along each one of the lines marked with 0, 45, 90, these are representing the degrees that the cam is turning in 45-degree increments. So I'm going to go ahead and just place points on these lines. When they're on the line, I will see a blue X that shows up that indicates that I'm coincident with that line. So I'm going to go ahead and set that there. Set one here on the 45 and continue on around on each one of these points until I have one on each one of the numbered points that I have. I'm going to right click and choose OK to close out of the point command. From here, all I have to do is look at, here's the origin, and then I need to look at how much of a distance from the origin do I need to dimension these values. Grabbing the sketch dimension tool, I'm going to click on the point here on the 0 degrees line, so clicking on it, and then I'm going to click on the origin. I'm going to make sure the dimension follows the line, so that way the dimension lines are parallel to the dashed construction line that we have. Following our points at 0 degrees, we want it to be 0.5. Then as I move to the 45-degree line, I'm going to go ahead and click on the point, click on the origin, but however, I want to make sure that my dimension shows up again. The dimension lines are running parallel to that construction line. If I get a dimension like this, I do not want that, and if I get a dimension like this, I do not want that either. So one thing to kind of help it along if you need is right click, and from the contextual menu choose Aligned. So the aligned will make sure that these stay aligned no matter what, and then I can go ahead and click to place the dimension, and it's going to give me a value of 0.625. Same scenario for 90. I'm going to go along, dimension 0.75, ensuring that those are going to stay. So I'm going to click on this line. Again, we don't always have to choose aligned, but as long as it's showing up, we are going to be good there. So at 135, we're at 1.1875. From the center to the point right here at 180, the largest point that we have, it's going to be 1.625. and then I'm going to repeat the exact same values as the numbers returned back. So 1.1875 for 270, we will be at 70.75. From here to where we're at 315, again making sure the dimension stays aligned, we're going to be at 0.625, and then we come back to 0, which is going to be at 0.5. So here's what the points are able to allow us to do. We are going to go ahead and from the Create menu, I'm going to go down to Spline, and I'm going to choose Fit Point Spline. And then to make sure that I get this correctly, I want to make sure when I'm on top of a point, I should see a blue square to note that I'm picking up that point. So I'm going to go ahead and click on it when I see that, and I'm going to work my way around counterclockwise, or you could go clockwise as well. But just kind of going from 0 to 45 and around just kind of makes sense to me. So I'm going to go ahead and go around until I click the next point, click the next point, and go all the way around until I finally get to back to the original point. The spline will complete. I can then right click and say OK to finish it. And then while I'm here, this is going to give us the cam shape that we were able to preview with a radar chart. Clicking Create, going to Rectangle, choosing Center Rectangle. I'm going to set the center at the origin, and I'm going to go ahead and make this 0.25 by 0.25 on the dimensions, giving me an opening for a square axle. If you're using a round axle, then you can always choose a circle. From here, I'm going to choose Finish Sketch, and then I'm going to go ahead and put this in the home position. Choosing the Extrude command, I can then click the cam profile, setting a thickness to 3/16, hitting Enter, and this will give us our custom cam that was shown to us from the motion graph. From here, you can go ahead and click Save. And this file could be exported and be 3D printed or laser cut, depending upon your preference and available tools and equipment. From here, I'm going to create a drawing to document this shape. So I'm going to go to File, New Drawing from Design, choosing the cam. I have a title block that I already have a custom title block selected, so I'm going to go ahead and choose it. I have an A-size title block, means it's on an 8.5 by 11 sheet of paper. From here, my cam will be represented. I could change this to a 1:1 scale if it fits well on the page. Looks like it will. And I can say OK to place the front view. From here, projecting the other views and placing an isometric view. Choosing center line, choosing my hidden lines to run the center line. And then as far as overall dimensions or anything like that, sometimes because of the spline tool, you're going to notice it's going to be pretty hard for Fusion to pick those up. So a lot of times to get the height, we may have to base this off of the right side view. Same thing for the width. We may need to utilize the top view. And some other things, like for example, that could be helpful. We could use a detail view. I'll make a little room here. Utilize a detail view. Click on the view, set the center right about in the middle, and go ahead and click, placing our detail view up here. May need to rearrange the label a little bit, but we can always dimension the point at which we have our opening. If I double left click on a dimension, I can type TYP. That'll keep us from having to show two dimensions. I'm going to just arrange this a little bit better. There we are. And really, when it comes down to it, not too many dimensions are absolutely necessary. Like for example, it's pretty hard for us to pick up a height off of this, or to get, in order to get some curvature or anything of that nature. The dimension tool just is not able to pick some of those up. So we dimension as much as we can, and then we're able to finish the drawing. I'm going to double left click on the 3D view, make it shaded, click close, and this would suffice as a fully dimensioned detailed drawing for our custom cam. So this video concludes how to create a custom cam in Autodesk Fusion 360. Check out my other videos for other help resources with the Automata project within Project Lead the Way Introduction to Engineering Design.